Welcome to Study Loop.
So here are two coils. They are carrying current in opposite directions, right? So there will be um, the magnetic dipole moment in both sides of these coils because they are carrying current in opposite directions, right? And the mu net is given as a function of the current in the second coil, right? And that graph is plotted for mu net versus the current in the second coil, that is I2. So I1 is the current that is flowing through the first wire. This is I1, this is I2. This is the initial case, right? Now, if you look at the graph, well, we can figure out some values of mu1 and mu2. So let's do that first. So uh, magnetic dipole moment for the first coil mu1 is equal to area of the magnetic coil into I1. Now, since this is fixed, we don't need to do anything about this. This is just fixed. This is mu1. Let us fix this as mu1. Okay, this is fixed. Now, magnetic dipole moment for the second coil mu2 equals to, this one is area of the first coil. Okay, this is equal to area of the second coil A2 and current in the second coil I2. Now, since the question says that the current in one of the coils current are in opposite direction, let us consider that I2 is negative, right? Because it is in the opposite direction. So let me write it as minus A2 I2. All right. Now, what is mu net? The net magnetic moment is the sum of magnetic moments, right? Magnetic moments. Okay, so this is equal to mu1 minus A2 I2, right? Now look at this equation here. This resembles to a straight line. Y is equal to C plus mx, where m is the slope and c is the y-intercept, isn't it? This resembles where y is the slope and m is the intercept, which means that this implies that the value of mu1 should be equal to the y-intercept c, right? So if you look at the graph, then the y-intercept of this line is the point at which this line cuts the y-axis, right? So this is a y-intercept, and the value of y-intercept, this is y-intercept here. So this is y-intercept c, and whose value is how much? So according to the scale, mu net s is 2 into 10 to the power minus 5. So c is also 2 into 10 to the power minus 5. This implies mu1 is equal to 2 into 10 to the power minus 5. Alright, ampere meter squared. So we found mu1. I hope this will be useful for doing problem further. And what can we do next is look at the graph again. When this mu net is 0, then current I2 is exactly at the center, that is 5 milliampere, right? So let me write that from this equation. When mu net equal to 0, then mu1 is mu1, that we know the value of mu1, right? Minus A2 times, what is the value of I2 there? 5 milliampere. So 5 into 10 to the power minus 3. So solve this for A2. So A2 will be mu1 upon 5 into 10 to the power minus 3. So 2 into 10 to the power minus 5 upon 5 into 10 to the power minus 3. So this is equal to 0.004 meter squared. So this gives me the area of the second coil of coil 2, right? This may be useful for solving the problem further. Now the question is asking what is the net. Let's move on to the exact question now. The question is asking what is the magnitude of the net magnetic moment when I2 equals to 7. I2 is equal to 7 milliampere and reversed, right? So reversed means now they are in the same direction. So since it is in the same direction, then mu net now will be what? Mu1 plus A2 I2, right? Because it is in the same direction, so not minus but plus. So what is mu1? 2 into 10 to the power minus 5 plus what is A2? We determine that 0.004. What is I2? That is given. Question is says I2 is 7 into 10 power minus 3 ampere. So just calculate all this. You get this is equal to 4.8 into 10 to the power minus 5 ampere meter square. Alright, so this gives us the net magnetic moment, and hence this is the solution for this question. Thank you for watching.